Our next presenter is Deepanjali Mishra from the College of Engineering. Deepanjali's title is The Hidden Energy Cost of Waiting in Computers.
Right now, as I'm speaking, some of you might be checking your phone, scrolling, texting, or maybe even opening Instagram. Feels instant, right? While preparing for this competition, as shown in this slide, I jumped on a call with my friends. I clicked a single button, and suddenly we were all connected. It felt effortless. But behind that single click is something enormous. Massive buildings filled with computers known as data centers, packed with millions of tiny chips working together to make that instant moment possible. We don't see or hear them, so why should we care? Well, these buildings consume tremendous amounts of energy, which is growing rapidly due to AI. This affects all of us in at least two ways. First, communities near these data centers now compete with them for resources such as power and water. And second, our electricity and gas bills have been rising rapidly. I'm not sure how many of you have seen. So, I am a computer architect. I design hardware inside these machines. At the heart of each machine is a processor. That's a chip that's capable of performing billions of computations per second. But even before it can compute anything, it needs data to operate upon, which resides elsewhere in memory, which is slower to access. So while the processor performs this data access, it's still powered on, consuming energy. It's like keeping your car engine turned on at a red light. You're burning fuel, but you're not really moving forward. So the key question my thesis asks is, how can we reduce this waiting time of processors in data centers? Here's something we all understand: patterns. Think about making your morning coffee. You grab a mug, you pour coffee, maybe you add milk. You don't rediscover this process every single time. You follow a pattern. So applications in data centers behave in a similar way. When you check email or load a website, programs often access data in nearby memory region. So my research focuses on identifying such redundant memory access patterns and merging them to reduce the total number of requests we perform to memory. So the next time you check your phone, send a message, or stream video, nothing will look different. But behind the scenes, there are millions of computers working together to make that happen, and my work ensures that they do so using less energy. Thank you.